Just doing a fairly simple project. These are a couple of Morini alternator stator plates, and it's the one on the left I'm working on. You can see it has a coil missing. You see the corresponding coil on the other alternator. This is a later type. So that's the high voltage winding from the alternator that powers the capacitively discharged ignition, and it produces up to around 300 volts AC, which is rectified and charges the capacitor in the ignition units. And the coils break down with age. You know, we're talking 40 years plus, and subject to heat and vibration, in particular heat. Normally the voltage produced by this coil would just rise linearly with engine RPM, but we don't want it to ever go above about 300, and we need around, say, 100 volts at kickstart speed to get the engine to fire when kickstarting. So you have to limit the voltage, and the way they did it back then is a copper plate which fits over the end of the iron, over the end of the coil, and that's a single short-circuited turn, and very high currents flow through the copper, create a magnetic field which then saturates magnetically the iron of the stator plate, so that no more magnetic flux is coupled into the coil, and that limits the voltage. But because this plate runs hot, all that heat ends up in the coil. Now you can see I've already stripped the bobbin off this stator plate, and you can see here what the bobbin looks like after I've taken it off. And this had been rewound previously, and perhaps not very well, but it looks like the bobbin has suffered some heat distress. So in order to get that bobbin off, it has to pass the two adjacent charging coils. The coils are retained by having one of the laminations folded down. So you can see on this coil I've very carefully straightened that lamination, folded it up. The ignition coil has a lamination top and bottom folded, and again this charging coil has had its lamination folded up. Now on this particular coil I just eased these two coils up very slightly, and was able to get the coil to just pass through the gap, you know, just by flexing these flanges ever so slightly. If we have a look at this coil, you can see that there's more interference, and in that case there may be no other choice to actually desolder the connections on these two coils. And you don't have to completely remove them, but certainly move them far enough out for this coil to come off. You've got to do this very carefully. There's usually some lacquer on here, and you've got to try and get the force into the bobbins to break them loose, get them to move. You know, you've got to be trying to wiggle them and make sure they're not jamming up, and just move them carefully. They're quite easy to break. This bobbin is of course not usable, but a while back I drew the coil up in CAD, and I had these replacement bobbins 3D printed in nylon. So this is a laser sintering process, and they came out really nicely actually, and I do have some of these available, but I don't know whether I want to do them as bare formers or only as pre-wound coils. But the next job is actually to put a new winding on this bobbin and refit it to the stator plate.